Okay, this is a little summary of what we did in class today on section 3.6, functions. We asked some questions about what does 88 stand for? Well, this is the number of mastery points you should have as of today, the 3rd of November. At 97, the number you should have by the 10th of November, and that will be our test day on chapter 3. So that's what these were about. And we said that chapter 3 was all about graphing. Well, how did function tie in with that? Well, we said a typical function notation expression, and we write the function of x, and these parentheses do not indicate multiplication, is such that 2x plus 3. Now, what we're going to be doing and tying this into chapter 3, if we were to replace this function symbol with the letter y, we get y equals 2x plus 3, which is slope-intercept form that we featured in a number of sections in chapter 3. But going on to the things we talked about, 4 vocabulary words: relation, domain, range, and function. And we said that relation, what does that refer to in mathematics? Well, that somehow things are connected. They're related. So we know one of the famous relations of chapter 3 was the ordered pair, the x and the y. So this is a good example of what we mean in mathematics as a relation. Now, when we consider just the x of the relation, this makes up the term that we call domain. Domain are all the x values of something. Range are the y values of something. And the word function, we had this special definition in which if the x element is only used once in a relation, then something is a function. And we gave the illustration that these are x elements, these are y elements, and we see the x element A is only used once. B is only used once. C is only used once. These are a relation, but since the x elements in this first column are only used once, this would be an example of a function. Where in this example we said that A is used with D, it's also used with E. So A, the element, is used twice, and that's in the x column. So this is not a function. Then we said, well, how about if they ask the question, write the domain of these ordered pairs? Well, we would take out the x of each one and place it here. So it would be a 2, 3, 4, Now, are the x elements used more than once? No, just once in each relation, and they're different. So this would be a function. Now, when we look at the range, we see we have a 1 here, a 4 here, and another 4. And the rule is if something is repeated, we only write it once. So here we're going to write a 1 and a 4. Now, for this one, they're asking us to find the domain and range of this particular graph. Now notice it's a line that extends from this point to this point. So all along this, what are the x elements? And we are to write this in interval notation. Well, the x elements are, it starts with a -2, so we're going to use a bracket, -2, and then up to 3, and bracket. Now I have another slide with all these filled in that I'll show you. Now for range, we're looking at what y values? Well, this point, the y value starts at -3 right there and goes up to a +3. So it'll be bracket -3, comma, 3, bracket. And we'll illustrate this on the next slide. All right, another test we often run across in section 3.6 is the vertical line test, in which we have a very, very thin vertical line that's going to travel over the face of the graph. And you might think this is positive slope, this is negative slope, this is zero slope, this is undefined slope, or the 4 basic types of graphs. Now here, that vertical line will only intersect in one place as you move it across. The same here. Only one place. The same here. Only one place. So these are examples of passing the vertical line test, intersecting in only one place as you move from left to right. These first 3 are functions. Now we get to this line, which is, let's say, x equals 3. This is a vertical line. Now as that vertical line test goes over it, it's going to coincide with this line, and it will intersect in an infinite number of places. So it's not just one. So any vertical line does not pass the vertical line test. This is not a function. And as we look at a circle, bringing that vertical line across, it's going to intersect in 2 places throughout this area here. So this is not a function. Now, what would be the domain of a graph that looks like this? Well, this is going to go to -infinity over there, and it's going to go to +infinity. So for our x values, it's from -infinity to +infinity. And the same holds true for our y values. This is going down to -infinity and going up to +infinity. Domain are the x values, are the range. Now notice that for positive and negative slope, it's exactly the same. For the horizontal line, the domain will go from -infinity out here to +infinity. And by the way, we always put parentheses around infinity. But for the range, our y values, it's only going to be 3. And we put 3 in a bracket to indicate it is included in the set, and it's the only member of the set. Now for our vertical line, our domain is only 3. That would be the only x value that you would use. But for the range, the y values, that goes from -infinity to +infinity. And for the last thing we did, we illustrated this one. Find the domain of this function. Well, x would be any real number except a number that would make this denominator a 0. And what value of x would make this denominator a 0? Well, we equal it to 0, transpose the -2, and we say x equals 2. So if x were 2, this would make this denominator a 0. So therefore, we exclude 2 from being a member of the domain. So the domain of this function is all real numbers, but x cannot be 2. All right, now let's take a look at it. And I have to do a little adjustment here. So not much new up here, but we filled in our answers here. That our domain is 2, 3, 4. We separate them with commas. Our range is only 1 and 4. If 4 is repeated, we don't write it again. And our interval notation for this graph, for our domain, it went from -2 up to 3. And for our range, it started with -3 down here and went up to 3. So for our domain here, we said that we equate the denominator to 0. So x is equal to 2. But 2 now will be the value that is excluded from the domain because it makes the denominator a 0. And we write that in interval notation. I have it over here. That is going to start at -infinity, going up to 2, parenthesis. Then I use the union symbol, and then it's going to start at the other side of 2. Because of the parenthesis, 2 is not included in the set, and it goes to positive infinity that we then close with a parenthesis. Okay, that was the little review of our lesson today, and it took me about 13 minutes. Remember, we have a video on this online, the full section. We also have additional exercises, and there's a review of Chapter 3's test that you can look at. Again, subscribe to our site, and that will make it easy for you to get there in the future.